Hey folks, problem number 4. So in this problem, they want a 95% confidence interval for sigma. So notice we're going to use the formula which has sigma in the center. And it looks just like the sigma squared formula, except all I did was square root everything. So the square root of sigma squared is sigma. And then the left side just a big square root, right side just a big square root. Okay. So if problem number 3 made sense, problem number 4 should be pretty straightforward. It's basically the same thing. Okay, so I like getting my chi-squared value, so let me draw my chi-squared, 95% confidence. I'm going to put 95% in the middle, so that's 2.5% over here, 2.5% over here. So I need to get to this location, and I need to get to this location. So to go from here to here, that's going to be 0.025. And then to go from here to here, the 2.5 and the 95, to get to this location, that's going to be add them up, 975? 975. So those are the two columns in my chi-square table. And then my degrees of freedom, if n is 26, degrees of freedom is 1 less, so n minus 1, so 25. A picture should pop up in a second so you can see what's going on. So we go to DF25, and we are stuck in row 25, and up top the 025, and then the 975. So I see 40.646 and 13.120. Okay, 025, that looks good. Okay, so sigma is between, don't forget the big square roots, n minus 1, so 26 minus 1, s squared. Remember, they straight up give us s squared, the sample variance. Sometimes they just give us s, sample standard deviation, so be careful. 11.8. So it looks the same over here, 26 minus 1, 11.8. And then I said, oh, so I'm pointing at my two chi-squared values, and then I remember, just put the bigger one over here. Oh, okay, that is a good trick, 40.646. And then the other one, 13.120. Sigma is between, and now we go to our calculator. Here's how I would do it. I like doing the square root last, so I would just go 26 minus 1 is 25, times 11.8, enter. I break it up into a lot of steps, divided by 40.646, enter. And now I need to take the square root of that mess. So I'm fancy. I would just say take the square root of the answer. Slide out of that, hit enter, and I would get 2.694. I think last time I went to the hundredths place, I usually just look at the number and then round with what's easiest. It'll usually specify how to round, but for right now, as long as we agree, basically we're good. Okay, now let me just crunch this. 26 minus 1 is 25, times 11.8, enter, divided by 13.120, enter, square root of that mess, square root of the answer, slide out, enter, 4.7418, Okay, so here is our answer. What does it mean? We are 95% confident that the true standard deviation is between 2.694 and 4.742. Ta-da! I think it's making sense, right folks? One more. Good stuff.